Welcome to the presentation of our paper Evaluating Difficulty Adjustments in a VR Exergame for Younger and Older Adults, Transferabilities and Differences. My name is Lucie Kruse and I will present our work today. In this paper, we evaluated a cognitive physical exergame with younger and older adults. In the game, users sit in a virtual canoe that runs down a river and they have to collect soap bubbles by touching them with their hands. Our main goal was to balance the game difficulty for players, but also to explore transferabilities and differences between those two age groups. Our motivation was that exergames theoretically have the potential to improve cognitive physical abilities in older age, and therefore help people to remain active and independent as long as possible. But this only works if the exergames are suitable for the user in terms of difficulty and usability. Otherwise, if the game is too difficult, it can be frustrating, and if it is too easy, it can become boring. Unfortunately, we developed and tested this game during the COVID-19 period with contact restrictions, especially to vulnerable groups such as older adults. This made it very hard to possible to test it with a large amount of older adults. We therefore explored the option of first testing it with younger adults and a small group of older people. We had 3 different research questions. First, we wanted to evaluate the effect of the different starting difficulties on the user experience, especially enjoyment, perceived workload, cyber sickness, user preference, and game performance. Second, we wanted to see if the game, which was originally developed for older adults, can also be adjusted in a way to be fun for younger users. And our third research question was which results could be derived from testing a VR exergame for older adults with a different user group, in this case with younger adults. I will now present our methods. The game starts with a calibration. First, we calibrate the range of motion of the player. This needs to be individually calibrated because of the different heights, arm lengths, and mobilities of the players. It is done by pushing 6 balloons as far away as possible. Then a shape is created in which the bubbles in the game can possibly spawn. Secondly, the difficulty is calibrated. In this setup, the users have 1 minute to collect as many bubbles as possible in a stationary position. The next bubble only appears after the last one has been collected. Therefore, there is no time pressure in the setup. The calibration in our study was done for 3 rounds, 1 for each level type that we have in the game. The levels differ by cognitive and physical demand, and there are simple levels, which are just about collecting as many bubbles as possible, coordination levels, which require different physical motions, and finally alphanumerical levels, which always present a comparison task with letters and numbers. With the difficulty that we calibrated in the stationary setup, the 3 different conditions are created. Perfect is exactly what we calibrated before. If, for example, the user collected 60 bubbles in the 1 period of the calibration, then perfect here means that 1 bubble is spawned every second. In the slower condition, this is reduced by 50%, and in the faster condition, it is increased by 50%. This only applies to the start difficulty though, and during the game it is further adjusted to account for learning effects and also because we wanted to explore a broader range of difficulties. Then we performed a user study. First, all participants filled out consent forms, then a demographics questionnaire and a pre-simulated sickness questionnaire. Then the game was calibrated in terms of range of motion and difficulty, as I explained before. Afterwards, the participants filled out the simulator sickness questionnaire again, as well as the interest and enjoyment subscale of the intrinsic motivation inventory and the Nasat helix to measure perceived workload. Afterwards, the 3 experimental conditions were played in a randomized order, always followed again by the 3 questionnaires. In the end, the participants had to state their preference on the difficulty. 30 young adults took part in the study with a mean age of 24.77 years. 10 of them identified as male and 20 as female. All users participated remotely with their own MetaQuest or borrowed one from the university. We also tested 9 older adults with a mean age of 75.67 years. 2 of them were male and 7 were female. Here we had 2 different groups. We had 4 adults in their mid-60s who participated from home on their own, while we also had 5 slightly older adults who participated with the assistance of a senior living facility and a Zoom call of the researcher because they needed a bit more help with the technical stuff. Now I will briefly present the results. Enjoyment was quite high for all the conditions. It was highest for the fastest condition, but no significant differences could be found here. The perceived workload was highest for the faster condition and lowest for the slower one. For the younger adults, this is a significant difference compared to the other conditions. While the faster condition received the highest rating for cyber sickness, the only significant difference here could be found for the calibration, where the score was significantly higher compared to before, but this only applied for the younger adults. Regarding the preference, the faster condition received slightly higher votes than the others, with a trend of favoring the rounds that contained more action. Another interesting measurement was the performance. During the game, for every difficulty that was experienced by any participant, we measured the percentage of correctly collected bubbles and displayed them in a graph. We fitted this with a loss function to better display the trends. What you can see here is that younger adults performed better than the older adults, at least until a certain point, and at around 1 bubble every 2 seconds, after which both groups achieve almost perfect results. With more than 1 bubble every 2 seconds, performance then steadily decreases. We have also marked here the point in time where more than 95% of bubbles are successfully collected, and for younger adults this happens at around 1 bubble every 0.88 seconds, and for the older adults a little later at 1 bubble every 1.3 seconds. I will now discuss the results in relation to our research questions. The first research question was how the starting difficulty affected the user experience. The slower condition showed the lowest perceived workload and pressure and the least missed and wrong bubbles, and therefore a high success. Nevertheless, it was not the preferred round by the majority of people. The faster condition, on the other hand, showed a high perceived workload and many missed and wrong bubbles. Nevertheless, the total amount of bubbles that was collected, and therefore the amount of exercise performed, was the highest here, and most people preferred this condition. So the main takeaway from this is that exergames should be balanced according to their intention of usage in order to achieve a high adherence and engagement with the game. It should be challenging, but at the same time enjoyable. The second research question was whether young users would still enjoy the game, which was originally developed for older adults. We could see in the results that the younger adults rated the game more negatively on all scales, for example with a lower enjoyment compared to the older adults. This difference could be due to the younger adults having more experience with games or VR and possibly higher expectations. Nevertheless, young adults also left many positive comments. We therefore assume that with the right adjustments, this game can be played by several user groups. This also opens up opportunities for multiplayer versions or intergenerational play. Here it is just important that the individual skills of the users are integrated to make the game enjoyable for all players. The last research question is about transferabilities and differences between the two user groups. One thing both groups had in common was that the differences between the slower, perfect and faster condition followed the same patterns for young and older adults. For example, in the perceived workload, with fastest receiving the highest scores and slowest receiving the lowest scores. On the other hand, the differences within the conditions, but between the groups, showed quite different results, with older adults rating the items more positively. Another transferability was that both groups were able to give good feedback about the gameplay experience, for example, pointing out what was too difficult for them. Younger adults, on the other hand, were better at providing feedback on possible additions or bugs in the VR game, because they knew what was potentially possible in games, whereas the older adults mostly accepted the game as it was. And the last difference, which is important, is the game performance. Here, the younger adults were faster than the older adults, and this clearly is a feature which has to be tested with individual user groups. We then performed some improvements in the game and run another short confirmatory study. First of all, we added a tutorial to facilitate the understanding of the game. Then, since we noticed that in the calibration users performed equally well in all 3 level types, we shortened this to just calibrate the difficulty with the simple level. Also, some comments implied that bubbles were sometimes out of the field of view in the calibration, resulting in a long search time. So for this, we decreased the space in which puppets could spawn to 65%. And lastly, we used the calibrated difficulty and increased it by only 1/3 instead of 50%, as it was done in the faster condition before. We then ran a user study with 11 older adults with a mean age of 83.82 years. The study was ran on-site at the living facility Hospital zum Heiligen Geist Hamburg. The game was played for 4 rounds with the calibration and 1 simple, 1 coordination and 1 alphanumerical level. Afterwards, 2 questions about fun and difficulty were asked. The results show that most participants had fun, with a mean value of 3.73 on a scale from 1 to 5. Most importantly though, the difficulty was rated as 3, meaning exactly right, by all of the participants. We also calculated a plot with the correct percentage of bubbles again, which is also interesting to look at. Here the 95% line was crossed later than in the first study, at 1 bubble every 1.75 seconds. We speculate that this might be due to the advanced age of the participants compared to the first group of older adults. This further highlights the importance of calibrating cognitive physical exergames to personal needs instead of just using default values. I will now provide the conclusion of our paper. We found that a higher difficulty is more enjoyable, but it also leads to a higher workload and worse performance. The recommendations of young adults help to improve the game, but difficulty adjustment seem to be a non-transferable factor, and exergames should always be pre-calibrated to ensure they are suitable for the participant. To conclude, an additional user group adds value to tests, especially when the actual users are not available, but the target group should always be included. Thank you very much for your attention, and if you have any questions, please feel free to contact me.